Hi everyone, in this video we're going to go through lesson 3 number 1. Specifically it was requested part D, but I'm just going to do the whole question. So again, I didn't know necessarily how to start this problem, so I drew the graph. And I saw the word triangle here, so I've plotted these points, and now what I'm going to do is I'm going to actually connect these points. Again, remember this is a sketch, so this isn't exact. As you can see, I can't draw that line very well there. Let's try this again. So this isn't exact, but it should give me an idea about what to do. We want to find the length of each side. So to find the length of each side, we simply apply the length formula. And since this is a triangle, what we can do is we can name these sides. We're going to call this side D, because remember, the opposite side would be named with the small case letter of the vertex. So that would be D, this would be E, and this would be F. And we know the length of a line segment formula. The length of a line segment is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And now let's do this for each case. So we're going to find, let's do D first, and D is equal to the square root of 4 minus 2 squared plus negative 2 minus 6 squared, which is equal to the square root of 2 squared plus minus 8 squared, which is equal to the square root of 4 plus 64, which is equal to the square root of 68. And I don't have my calculator here, so I'm just going to leave it like that. Erase this a little bit. Okay, let's do the other ones. Let's change colors to help us see what's going on here. F is equal to the square root of negative 4 minus 2 squared plus 4 minus 2 squared. So we'll do a couple steps here. This is going to give me 36, because that's going to be negative 6 squared plus positive 6 squared, 36, which is equal to the square root of 72. Again, I'm going to leave it like that. Now let's get another color here, and let's figure out E, and E is equal to the square root of, let's see, and this time I'm going to read it right off. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 squared plus 1, 2, 2 squared, which is 64 plus 4, which is 68. So just a little thought here. All of a sudden, a little bell's going to go off my head and say, two sides are equal. Well, if that's the case, we know this is an isosceles triangle. So therefore, if I find the midpoint of DE, which would be right here, I can see on the diagram, and I went straight down like this, and I plugged in the median there, the median would be the same as the perpendicular bisector. So interesting thing to kind of watch for. So if you get side lengths that are equal, start thinking about equilateral triangles, isosceles triangles. The coordinates of the midpoints of each side, and label these points x, y, and z. Now again, I've drawn these as a picture so we can see them here, and let's put this one here. We see this one's here. We see this one is right there. But again, if I didn't know how to do this, let's call this x, let's call this y, and let's call this z. If I didn't know how to do this, I'd just simply use the midpoint formula. So the midpoint, actually let's do that. So the midpoint formula is simply x1 plus x2 over 2, y1 plus y2 over 2. So therefore, x is going to be minus 4 plus 4 over 2, comma, 4 plus 6 over 2. So x is going to give me 0, comma 4 plus 6 is 5. 0, 1, 2, 3, 4, 5. That's good. Y is going to give me, just erase a bit of this there. Y is going to be, let's see, 2 plus 4 over 2, comma, negative 2 plus 6 over 2. So Y is going to be the point 3, comma 2. That checks out. Now remember, these are points, so there's no equal sign in between the name of the point and the brackets. And Z is going to be negative 4 plus 2 over 2, comma 4 minus 2 over 2, which is going to give me negative 1, 1, which makes sense based on my diagram. Okay, so now let's scroll and let's get a little more space here. I'm just going to pause for a second. Oh, the wonders of technology. I was able just to copy my diagram from up here, just down again. So we're finding the slopes of each side. So therefore, I'm going to find the slope. And again, I can indicate my side by saying the slope of df, little subscript there. So we're going to have, remember, it's change in y over change in x. So it's 6 minus 4 over 4 minus minus 4, which is going to give me 6 minus 4 is 2 over 8, which is 1/4. Whenever I calculate the slope, I always then ask myself, do I feel good about this? And of course I do here, because I can count it off. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And remember, a slope is a fraction, so we want to reduce that. Also, the slope is positive. So now let's do the other one. The slope of DE, and that's going to give me 4 minus minus 2 over negative 4 minus 2, which is going to give me 6 over negative 6, which is minus 1. Again, I can read that right off the graph and see that's right. And now let's do the slope of EF. So that's going to be 6 minus minus 2 over 4 minus 2. And I should get a positive slope here, so we see we get 8 over 2, which is going to give me 4 over 1. So let's check. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And again, remember, we can't possibly state every rule explicitly, but we always want to be going back and thinking about our types of triangles. And you might notice something interesting about those two slopes, and tie that into the type of triangle that we're working with. Okay, these types of things we always want to keep relevant in our mind. So now, specifically, the individual was interested in part D, the slope of each segment connecting the midpoints. So all that is asking for, so in order to do this, actually, the slope of each segment connecting the midpoints. So if I go, and it says connecting the midpoints, so let's connect them. So we're going to connect that midpoint, let's connect this midpoint, and let's connect this midpoint. So what it's asking for, essentially, are the slope of, it wants, and actually this, we'll keep working this color. We want the slope of ZY, and I'm writing these out specifically. You'll see why in a second. I have to pause here. I want the slope of XY, and I want the slope of ZX. Let's get our colors right. So I was a little slow there, and you'll see why that was in a second. So let's actually figure out the slope of ZY. So we see, let's just write down Z here. So Z is the point, -1, 1, y is the point 3, 2, and let's actually write down x here as well. X is the point 0, 5. So watch what happens here. So let's go 1 minus 2 over 1 negative 1 minus 3, which is equal to negative 1 over negative 4, which is equal to 1/4. See anything interesting? Okay, let's do the next one. So xy, so x is going to be 5 minus 2 over, so that's 5 minus 2 over 0 minus 3, which is going to be 3 over negative 3, which is equal to negative 1. Notice anything yet? Now let's do the last one. So we want zx, so we're going to have 1 minus 5 over negative 1 minus 0, which is going to give me negative 4 over negative 1, which is 4 over 1. So I want you to pause for a second and ask yourself, see if you notice anything interesting about the slopes of the sides of the triangle and the slopes of the lengths that connect the midpoints. And what you'll actually notice is an interesting pattern here. Notice 1/4, negative 1, negative 1, 4 over 1, 4 over 1. And what this eventually leads to is the observation that if I know the slope of say, if I'm given just the midpoints of a triangle, what I can do is I can actually take this length here, and if I tack it on there, and I tack it on here, I'll get the two endpoints. I can take this point, let's change our color now. Let's go blue, zy. If I take this point here, this length here, I can tack it on there, and I can tack it on there. And if I take this length here, I can tack it on here, and I can tack it on here. So a number of us have tried a problem which was, given the midpoints of a triangle, find the vertices. And by making this observation about the relationships and the slopes means that I can very quickly find those vertices without the long algebraic approach, which is very valid to explore because it uses systems of equations and such. But this is a little bit of a faster way, making a nice geometrical observation. I hope this video helped. If you have any questions, as always, don't hesitate to let me know, even if you're not my student. Have a great day.